Hello, everybody. I'm Savvas. I'm on the red team of Danske Bank, and red means bad, so we are dealing with offensive operations in the red team. We are actually pretending to be the hackers, and we did it for a very good reason. We actually create the patterns for the blue team, blue means good, so they can be ready when real hackers will knock our door. So we are actually hacking the bank. So the setup you see right here, on the left, obviously with a dragon, is the attacker. So it's gonna be the computer that I control. And on the very right, this Windows 10 classic theme, is gonna be our target. So we will execute things here, and we will see things happening on this side. So, the most common question that I get when I explain to somebody what I do, that I'm a hacker, is, can you hack my Facebook? This is the #1 question. So, guess what? That's what we're gonna do today. That's how we will start. I would love if somebody would volunteer to. I know this sounds funny, right? So I'm not getting your password. I will just grab your session, so no information of yours is going to be exposed. Is there anybody that would like to come on stage? Yeah, you can come. It was 50%, sorry. You just need to log in. So in this absolutely normal computer, which we will pretend it's your laptop, we'll go there, normal Facebook, you see.
But if I not remember my password?
I am already logged in, so let me log out.
Yeah.
Actually, so let's close and reopen it. So no cast session there. So now you can log in. I will not look. Okay, you logged in. Perfect. Just press cancel there. Awesome. Okay. So I will bring back view as before. Okay, and now let's not show Facebook. So, by the way, what's your name?
Justina.
Justina?
Yes.
Okay. So, Justina just logged in, but for now we will just not show her profile. But we know we're logged in, right? Actually, I'm even gonna close the browser. Things will be more realistic like that. So, if I would ask you now, what is that? What would you say? It's the most obvious thing, right? Everybody has at least 5. So yeah, it is a USB flash drive, but this specific USB flash drive has some extra functionality. The way it works, I guess that it's gonna be better if we just show it on the screen. I will put it full screen now, this, and I want you to be very careful on what is gonna happen on the bottom left side of the screen. I just plug it in. Wrong side. So after a few seconds, we see that, and we're done. Job done. Now, hopefully, if the demo gods help us, I have already hacked you. So let's see. So we go back to the left side again, and now this tool that you see right here now is a tool that is called FileZilla. It's a tool that I can access my remote server. My server is standing somewhere in the world. It's not this computer. It's another server that I'm remotely connecting to that. And the folder that you see right now, the files that you see right here, this access log, is data that has been sent back to me from this computer to my remote server somewhere in the world. I will just open this file now. I'll just, with a normal text editor, it's gonna look bad, I can tell you. But what we see on the last line, a few minutes ago, actually this is UTC, so don't be confused. 1 minute ago, on 8 o'clock, we got a GET request with some information. So what we see here is called session cookies. And it's the way that browsers remember that you logged in some time ago. Now, if we open Facebook here again, if we just start Facebook and just open Facebook, somehow magically it remembers me. But browsers do not have memory. So the way that browsers remember is session cookies. That's how it's called. This data is stored encrypted normally, but we can decrypt it, of course, we're hackers. And we steal this data and we bypass the whole password authentication thing. So I will just get this data without losing any more time. I will go on my hacker's computer, Facebook. You see, I'm not logged in. I'm gonna go there on some advanced tools. We're gonna go on application, and there we see cookies from Facebook. And then we see two things here. We see a cookie named C_user, Control C, go there on my browser, Control V, and the value is this 1000 whatever. Paste it here in the values. One is done, and the second one is this XS, just XS. So go there, paste XS, get this long nonsense string. We call these strings in programming languages. Actually, did I get it all? No, I didn't. I messed up. Yeah. And we're done. We close this and refresh the browser. And we're something that we like to say. Yeah. Now those, thank you. Now those session cookies have an expiration date, which means that if I wouldn't log in, I wouldn't use them, they would expire. They're cookies, they expire, right? So these also get expired when somebody manually logs out. So if I go back to my computer, we log out. So we devalidate, if this is a word, the cookies that somebody else stolen. When on this browser I refresh, let's see, we also logged out. So that's a good way to protect yourself and not leave active sessions running on your computer. Log out, just log out. It's super easy, right? So this was the Facebook hack. So now let's see something else that is also interesting. We have a lot of physical stuff today. Do I have time? I do have time. Now, another difficult question for you. What is that? It's a cable, right? Isn't it? Don't be fooled by these oranges for me to distinguish it from normal cables, because obviously it's not normal. So what I have here already plugged in is a normal USB-C to Lightning iPhone cable. And this is my absolutely normal iPhone. So I just plug it in, as I would do. It started charging, you hear the sound, I hope. We can also, most likely, we can see that on the file system. Yeah, there we are. And if I give it permission, it will also show all my pictures, so I will not do that. And now, this works fine, phone is charging, I am happy, everybody's happy. What's the problem with this cable is that it also has some advanced functionality. Now, if you, maybe on the front line, because you are close, but you can try, everybody can try. If you open your Wi-Fi now, you will see an access point. That's how access points, that's how we name. When you scan, we call those access points. This list is called various access points. You will find one named TechNight-demo. You can see it already. This is an access point that's been projected, it's been broadcasted by the cable, so another person can, who knows the password, me, can connect to that, and instead of statically, when I just inserted the USB, automatically after a few seconds it started typing things on its own. Now I do have control of when things will be typed. I can connect there, and I am already connected there. And I can go to a very special website, web application. It looks like that, nothing special. Let's refresh to see we're still on. Okay, yeah, we're still on. I can choose something here to be executed. So let's say, let's see. So I can choose one from the list. It's all different things that I have prepared to be executed. These are my payloads, that's how we call them. And this can do something. So one very easy payload, very small, that I have here, is gonna put this computer into a fake update state. So let's say that you are not looking for this for 2 seconds. I can remotely, with my iPad, go there, press a button, wait a few seconds, and we should see stuff happening there. We should see, yeah. And now you think the computer is updating. You went for lunch or somewhere, and now you think the computer is updating. This is actually gonna start going upper, so 1%, 2%. Now I have all the time of the world to think of my next attack, again from this magic device, and choose the next thing that I want to execute. Number 4, yeah, load it here on my iPad. I could also do it on my mobile phone, by the way, it's not different. I'm just gonna have to connect to the access point, to the Wi-Fi. And now, let's go back to the attacker, explain something. Here, what you see here, we call this in the hacking language a callback session management. Callback, you see the word callback there. What's callback? Callback is when this guy, our target, will send back information to this guy telling, hey, I just got hacked. You can do whatever you want with me. That's a callback. So right now, as you can see, we have no active sessions. We haven't hacked anybody yet. But we have a job running. A job is like a listener. We have our hacking ears listening for connections from possible victims. So without talking more, I will go ahead and execute payload number 4 this time, again for my iPad, while this guy thinks he's updating. And something happened really quick, and now we should see something on the left side of the screen, if demo gods help us. Yeah, there we are. Come on. There we are. So we see this message that's sending stage, whatever, some amount of bytes, and interpreter session 1 just opened. So now if I click sessions again, we see we have an active session, and we also have some information here and some not like informative stuff. What this software can do now, what this session handler, session manager can do, I can go and I can start interacting, -I, number 1, we have 1 session, with this. And now this will open a shell like that. So if I just now put a question mark, we can see all the crazy Hollywood-like functionality that we have on this poor guy. We can control the webcam. We can play sounds. We can record the microphone. We can scan other devices. Maybe you got hacked, but my final target is not you, it's your husband, it's your wife, it's your kid, it's your television, whatever it could be in your house. I can do actually all sorts of kind of stuff. I'm not gonna even tell what I can do. Just for the demo, I will just get a webcam snap. And now, not a good picture though. And now, yeah, we just got a snapshot of this guy. Awesome. Now, there's one problem. Those sessions, those callbacks, are static. So this guy, this thing, got executed once, very quickly, but at some point, we will restart the computer. So there is this software, again, offers a way to persist our foothold on this. This is called persistence. And we often do it on computers that will reboot at some point, like user computers. On servers, it's not needed because a server will reboot not that often. A server will remain open for weeks, maybe months. So persistence is not in there. But since we are hacking a guy here, we will just super easily, I have already prepared what needs to be run, and simple as that, saying set session ID, which is 1, and then just clear the screen, just click run. It's that hard. So some stuff that we do not hear happened, some things got installed right now, and we can continue doing our job. We can continue listening for other guys. Now, we will not do that. We will just start interacting again with our first guy. And what happens after every Windows update? We have a reboot. So we will reboot the guy. Let's see now, in a few seconds, this computer will be up again. Let's see if we get our callback again. And this confirms our persistence. If I will clear the screen, if in a few seconds now, I will once again see stuff happening there, because as I said, my job is still running, I'm still listening, and I will listen forever most likely if I'm a bad hacker. We should see stuff going on. So let's turn on again. We are already connected to our home Wi-Fi. In this case, this is the 4G router that I have in front of me. And after a few seconds, we should, yeah, there we go. Another stage. Now, doesn't matter how many times we will reboot, we will have a foothold on this guy forever. And it's all about how evasive our malware is until an AV detects that. But I can tell you for sure that if some malware developer wants to hack you, they can make a malware that is undetected from McAfee, from Windows Defender, from Bitdefender, call it whatever you want. So the most important thing is to not get hacked, but not to say that, okay, I have an AV, I can do whatever you want. No, you cannot, unfortunately. Now, enough with this. We will see something else. The same way, really quick this time. The same way of you getting hacked. Until now, we have only seen physical hacking with cables and USBs and all those sorts of stuff. But we haven't seen remote hacks. So we don't need this anymore. And now let's say that you were looking for an application and you only managed to find it on one place. We hackers like to do proof of concepts with a calculator. So whenever a calculator pops up, it's the proof of concept for us. So let's say that from Google search or from a friend sending to me, I found the Hackulator, so the most amazing application that can do anything, and it's definitely not malicious. So I can trust that. So I can download it. It's a normal, I already have it, so no need to download it again. We will go to our downloads, execute the Hackulator setup.exe. It's a normal setup.exe. Next. Here we have the usual stuff that 1 out of 100 reads. I accept. Yeah, next. Create a desktop icon for me. Yes, please. Give it a few seconds and we're done. We will not launch it yet. I do like to go right-click and open file location so I can see what files are there. I see a bunch of files like every other installation that you would get. And then I close and I just open my application. Now, I want you to look at two things. Number one, we have a calculator. We indeed downloaded something that works. So we are happy. Number two, somebody is watching us. We just did another session being open. Yeah. Obviously, I'm not going to get in the session. It's exactly the same session. I have full control on this poor guy once again. And so be very careful with the freeware that you download. You never know the cracks you overwrite legitimate installation with. The freeware that you download, some software that can do XYZ job really good and it's free. You always have to look, one, if the provider is trusted, generally trusted, if it's a well-known guy or something like that. And second, just take a look on if this setup is certified. So I have a legitimate installer here of Notepad++, a text editor that I like, and you can see the difference. We have one more tab here called digital signatures. So it means this installer is trusted. Somebody's information is on some authority. So if we get hacked or this software is proven to be malicious, somebody will get sued, and it's gonna be bad. Yeah. So this guy has no digital signature, so we can definitely not trust it. That was it from me. Yeah.
Thank you, Savvas. And now, maybe there are some questions from the audience.
Short question, can you please sell me that USB?
Fun fact, these are not that expensive. I forgot to mention that. I mean, they are really cheap when I say not that expensive.
Is it possible now from, let's say, a victim PC, if I'm a victim, let's say, check the packets or whatever from the networking side, whether or not my information is being sent somewhere, and how to see it, let's say, yourself? How to...
On the network level, you mean?
Yeah.
Yeah, of course, it's possible to see on the network level, but it's difficult because most of the times the tunnels created from hackers to victims are encrypted. So yeah, having local access to this, to the infected guy, you can do it. It's actually, that's what the forensics team will do, actually. When guys are doing digital forensics on other guys that have been hacked, that's exactly what they do. They go low and low and low and try to investigate the shortest bit of information, try to find what happened. But yeah, of course you can do. It's a difficult procedure. It's gonna be hard for you, and it's gonna be encrypted. A lot of encryption. So.
Okay, thank you.
Guys, so today you showed something that's going to happen with your laptop, and the laptop, of course, like for example, the camera, at least you can cover it with a sticker or something. Any tips on the phone? Because yeah, of course, like microphone or laptop, maybe you cannot actually disconnect it anyway physically to make sure at least that you're not listening to it, but at least with a phone camera, any tips? So
yeah, of course. Since if you go to your settings on any phone, iPhone, Android, doesn't matter, there is an option called permissions that you give to an application. So if you download an application, let's say that is I don't know, it's managing your photos. Let's say it's editing your photos, right? And this application requests access to your microphone. Something is obviously wrong. So you should be very careful and very suspicious with your permissions. You should check what kind of permissions each application is asking. Sometimes we users allow the easy things and we just click allow all. That's the worst thing you can do. There's a lot of malicious applications out there. It's the easiest options from user perspective, but it's also the most insecure.
Just very quick one. So the attack vectors that you showed are physical mostly or social? I know that, okay, I used to be with Danske Bank, and there are a lot of policies in place. So just to make sure, you just set the USB device policy to something like allow sound devices only, and that would prevent most of the rogue USB devices from getting in, right? So
that's a good question, actually. As long as you can plug in a keyboard or a mouse, third-party keyboard and mouse, to the USB slot and it will work, this is where those things will work as well. So there are some drivers, low level on the operating system, like the generic keyboard driver, generic mouse driver, and if you disable those drivers and allow specific models of mice, let's say, to run, then you're prevented from this attack. But as long as you allow generic drivers that make your life easy with Windows, I just plug in a Logitech keyboard and it works, then you have a problem.
So those present as keyboards and mice.
Exactly. That's something I didn't mention. Those are actually, the driver that is running in there is a keyboard driver.
Yes.
Yeah, those are keyboards.
Yeah.
Okay, any more questions? Okay, I see a question there in the far end. I'm running to you.
Yeah, thank you for presentation. And you mentioned that it's basically possible to do that. The malicious code is not detected by Defender and any antivirus systems and so on. But I can see that it's based on network. So what about that means that if you have a firewall, for example, blocking all other ports except browser, so does this protect you from these kind of attacks?
Well, kind of, yeah, it would protect, but hackers can be really clever and do all sorts of crazy stuff. So one thing that hackers can do is encapsulate the whole traffic into via HTTPS. This is called encapsulation, and this you actually do a tunnel in tunnel. You do an onion-like encryption. Don't confuse it with onion routing and torrent, all like that. You just do an encryption and one more encryption on top of that, and you transmit through another port. So if just one port is allowed, then yeah, most likely you can get hacked through this port. It doesn't matter if it's HTTP, 80, 443, SSH. Encapsulation can happen on any port.
Hello, nice presentation.
Thanks.
So my question is, I noticed that you're running this on the local host. You're not running any virtualized environment. My question is, when you want to clean up your exploits on payload, do you just reimage, or you've condemned this machine to
On which? On the target? On
the target?
The target is a normal host. It's not a virtual environment.
Yes, I understand. That's what I'm saying. Do you clean up?
Yes.
After a demonstration like this, and I'm asking, the cleanup, do you just run a script to clear off all your payloads, or you reimage the host?
No, since I know what payloads have been executed already, I know which places should I clean up. So I will just run the script that cleans that. Yeah.
I'm just curious, how does the day of the pen tester look like?
In short.
In short, yeah. So the pen tester or the red team? It's a different thing. Is it the pen tester or the red team? Red team. So in the red team, we try to find, so the difference between red teaming and pen testing is that pen testers are really good on breaking down a specific application. They will get an application and they will dig deep into that, into the internals and the system, and they will find everything that's possible. And the red teamers will not break down fully an application. They will just find whatever they need in order to move to something else. So the red team will create attack chains, whereas the pen testing will create reports telling you why this application is not good. So in the red team, we of course perform penetration tests. We crack down applications and try to find flaws and vulnerabilities there. But we also do create attack chains. So I can go into a web app. I can see that this web app is misconfigured, so I can most likely do something else, cross-site request forgery, then get remote code execution on another server, create the whole thing. From this server, go to somewhere else, moving laterally all the time until I go to the place that I want to end up to. So day in the red team looks like that. So you start with an application or with a system in general. You see what flaws or misconfigurations might be in place, scanning the application or just playing with the application. And then if you manage to break it, you see how you can use that, how you can exploit that, move laterally. That's what we do actually. We have those engagements that we start from something small and we try to make it as big as possible with the biggest impact.
How different would your hacking be on an Apple computer? Would it be the same or something different you would do?
It would be different payloads because let's get an example of the cables. So the first keystroke that I start my execution, my payload execution, is the Windows key and the letter R. This brings up this prompt. In an Apple computer, I would have to do, let's say, command space, so I can get into the search and then type terminal and then click enter. This will give me terminal access. So it would be a different key combination that I will need to type, but it would be mostly the same. Not that much different. Just the buttons that would be changed. Yeah.
Okay, thank you. Thank you, Savvas. Round of applause. Thank you for your questions.